Hello, everyone. November 20th. Alright, that was very bad today. I have a meet coming up tomorrow, and I was skateboarding earlier, and I fell. Hurt my wrist, hurt my knee. I seriously doubt that they will be in good condition tomorrow for the meet. And plus, we didn't solve the problem yesterday. Yeah, things are just not going well, honestly. Alright, count unguarded cells in the grid. You're given two integers, m and n, representing a zero-indexed grid. You're also given 2D integer array guards and walls, where guards I and walls I represent the position of the ith guard and the jth wall, respectively. The ith guard and jth wall. A guard can see. Oh, guard. Oh, guard. A guard can see every cell in the four cardinal directions, starting from their position unless obstructed by a wall or another guard. A cell is guarded if there is at least one guard that can see it. Return the number of unoccupied cells that are not guarded. So I have guards at these positions and I have walls at these positions. And basically, what we want to see is the number of unoccupied cells that are not guarded. So for each guard, I can look at four directions and I can fill it up, basically, right? You just fill it up. 10 to the 5th and 10 to the 5th. 10. Yeah, so I just filled it up. And then I move on to the next guard. So basically, for each guard, you just, fill it up. But you might do repeated filling. I think that's what we want to avoid. We'll be doing repeated. So like if I have a guard and I go down and hit another guard, I will just stop, right? And I think there will be repeated, like this one. Like some is repeated. But I think the overlap will be kept to a minimum, right? Overlap will be kept to a minimum. So for each one, do I just go through that, or even better, we just go look at each one instead of doing this? We look at each one, right? And for the gods, so this one, right? And I can look through the gods on both x-axis and y-axis. And on the rows, so this one is 0, right? So this position is 0, 0, 1, 2, 0, 2, right? So I have 0, 2. And I have gods that can look into row 0 and column 0, right? And then row 1, column 1. Like row 1, column 1. And then row 2, column 3, right? So this is what it is. So for the rows, right, so we say 0 is monitored, 1 is monitored, and 2, 0, 1, 2, all monitored. And for the column, I have 0 monitored, 1 monitored, and 3 is monitored, right? So this is all monitored. And I also have walls, right? Walls. And walls. And based on walls, walls can block it, right? Walls can block it. I don't know. I feel like this is not as efficient as you just go through the whole thing, Just go through the whole thing. What are you worried about? Just go through the whole thing. Like for a guard, just go all the way down. Like you say 0, 0. So on the 0, I start going until I hit a wall. So I stop, right? And if there be some crossing, then we do make a few of them, like overlap a few of them, but I think it should be not as I think it will not be too much overlap, like too much cells we have to do, say, twice. Like in this example, this cell gets hit twice, and this cell gets hit twice. So the only cell that will get hit twice is if we have plus what we can also do is no, like what if I have a guard here, and now we have some here, and I have a guard here. Sorry, so from this one I can go and I hit. So I set. But when I hit this one, I go this way. I see a set, right? But how do I know exactly? That's actually not. How do I know that they have all been set already? So that's what I kind of want to do a different way. To go through each one and see if it can be accessed by the guard. But I mean, for each one, I definitely look for directions, right? And if I look for directions, on one direction, so what I want to know is on one direction, on all four directions, can I see a guard, right? Can I see a guard? So let's say in this one, I look up. How do you know there's a guard up? Because in this column, right, I have the guard position, and I have, so for each direction, I just need to know if in a direction I'll hit a guard or I'll hit a wall, right? How do I know that? So in this in a row, you'll have the position of the guard and the position, like for the zeroth row, right? For the zeroth row, the guard position is 0 and the wall position is 1. The zeroth row. And for the 1th row, the guard position is 1. The wall position is 0, 1, 2, 3, 4, right? And for the 2 row, the guard position, actually no, you need to see which one is guard and which one is wall. So guard. So I need to say the guard is where, and the wall is where. And then what? Or maybe I can do, 0 is a guard, 1 is a wall. We change the data structure a little bit, So I can say 0 is a guard, 1 is a wall, right? And here 1 is a guard, 0, 1, 2, 3, 4. 4 is a wall, right? And in this case, 0, 1, 2. 2 is a wall, and 3 is a guard. Okay, so if we do it this way, how could this help us? So let's imagine you are a cell, right? So you're this cell. Okay, so this cell is 0, 2. So I'm on row 0, so I check the row 0, right? And I am at position 2. So we can binary search this because it's sorted, okay? So we'll binary search this. How do you binary search this? Doesn't matter, you can just do whatever, doesn't matter. So the 2 binary search, okay. And then I check the 1, to the left and to the right, right? If the one to the left to the right, any one of them is a guard, and then I have been watched. But in this case, it's a wall, so this one is not watched, right? And of course, we'll do the same for the column. So if we do the columns, so the zeros column have a 0 position is a guard, right? Okay, let's remove this. And let's remove this. So basically, these I have rows. Now I have columns, okay? And in column 1, I have 0 position is a wall, 1 position is a guard. Column 2, we have 2 is a wall. Column 3, we have 2 position as a guard. And column 4, we have 1 position as a wall, right? So now let's say we given this position, okay, 0, so 1, 0, 1, 2, 3. So 1, 3, okay, 1, 3. So 1, 3, I look at row number 1, where binary search 3, it's in between, and it's being watched. So done, it can now work, right? And let's take a look at this one, right? 0, 1, 2, 3, so it's gonna be 3, 0, 1, 2, 3, 4, 3 and 4, position 3 and 4. So look at a row 3, and row 3 does not exist here, right? So there's nothing. And column 4, binary search, they give you a wall, so that's not being watched. Okay, so I think this will work, and the data structure, I am not so sure about the data structure. I think I'm gonna do a map. I think I am going to do a map, and it might take some time, but I think map shall give me the best opportunity to get this one done. So I'll do a map, okay? So we'll have 2 maps. So it's gonna be integer, which is a thing, right? And then we also have I think it's gonna be a list of integer. Oh, a list of not integers, but list of and I need to store them, right? Oh, this one does not. Yeah, so it's gonna be a list of integer like this. Okay, so we say rows. Okay, and then we'll do the same thing for columns. All right, so what we're gonna do is for int g of guards, and we'll put guards at 0, walls at 1, okay? And what we're gonna do is rows dot put if, okay, the hash map was not right. Right, so rows dot put oh my bad, it's not right. Okay, so this should be right. Yeah, put if absent g0, that's a row, right? And then new array list, okay? And rows dot get g0 dot add new int, so it's going to be g1, right? It's column, and because it's guards, I put a 0, okay? And we'll do exactly the same thing for columns, right? That's gonna be 1. This is also columns. dot get, that's gonna be 1, that's gonna be g0. Okay, so now we'll do exactly the same thing for walls, right? So walls, and so all the g, so I can actually do this, all the g is gonna be w. I don't know if it's gonna work. No, it's not gonna work. That's fine. All the g is gonna be w's. Okay. Now we can sort them, right? We can sort them. So we say for can I do list? Let's just do int key of guard, not roles dot key set, right? We say roles dot get key dot sort comparator AB integer dot compare I believe it's A0 and B0. I wonder if we have to do this way, but that's okay. Well, the prep is very long. That's actually getting me a little bit worried. Alright, so now we do all this, okay? And then we say rest equal to 0, and then we say for int I, 0, I smaller than m, I plus plus. How do you know if, well, if it's, if it's on it, right? If rows and column both are on it. Hold on, let me think. We are on something, right? And then on a column, it's also on something, right? So if on a row, and I'm binary search, yeah, you hit something. Yes, that's something we don't want. Okay, so int j is 0, j smaller than n, j plus plus. All right. So we have ij. So what we want to do is for the row, okay, for the row, and we can say list. We don't have to do that. We can just do, say, index is equal to rows. If row stock contains key I, right? It's like if it contains key I, and then we'll do something else. Yeah, just whenever we find out that it's being watched, then we just move on, right? If we have not find out, then yeah, so if it contains key I, then we can say int index shall equal to rows dot get I dot binary search. Actually, I'm not sure if that's the way to do binary search. Maybe we should do, how do I do list binary search? List binary search. Collections dot binary search. Okay, so we do a collections dot binary search list, right? Binary search, the list is going to be rows dot get I, and key shall be what's the so we need a comparator. I think we need a comparator. So the key is J, right? And then comparator, well, how do I write comparator? Oh, here. Can I even do it if it's too different? I guess it's not. Because this is of, maybe I can do new int, I don't know, j and j. We don't really care what, right? So this is going to be comparator AB, say integer dot compare a0 and a b0, right? So kind of this is what the index give, and if index equal to 0, then that's just will continue, because this one is not, is definitely does not count, right? Unoccupied, it's occupied, right? If index is larger equal to 0, then we continue, right? We say it's cell is occupied. Otherwise, index shall equal to minus, I believe it's index plus 1. Right, this is the next one. So this is the next one, so we need to check that, right? And check the one in front. If one of them is a guard, then we are not going, that's not going to work, right? Okay, so how do we check? So what we say is if index is smaller than if index is smaller than rows dot get I dot size, okay, because this is the next one, and it's equal to and rows dot get I dot get index 1 is equal to a guard. Oopsie doozy, this should be a wall, which means should be 1, right? So this one situation is the one to the right is a guard, or you can say index is larger equal to 0, right? And rows dot get I dot get index minus 1. Actually no, it should be larger than 0, right? Because if it's 0, then it's, yeah, so if that is the case, right? So these are two cases, and actually I didn't even check the second case. So if this dot get is equal to 0, which means if the one to the right of me is a guard, or the one to the left of me is a guard, if that's the case, then we continue, right? Then we continue. So the cell is occupied. This is at least one guard, can at least visible to at least one guard, right? So that's also not good. Incompatible. Wait, what's that? Oh, yep, I know what was the issue. So this should be 1, right? So yeah, these are only two situations that you'll continue. And if it does not contain, that's perfect. And then we say if columns shall contain key j, right? If it contains key j, and we're basically trying to replicate this entire thing. So copy it, paste it here. Index is just going to be columns dot get j, and this is going to be I and I, it doesn't really matter, the same. Save that out here, let's continue. How do I do this? And then we say columns dot get j size, and then columns dot get j is equal to 0, and then we say columns dot get j dot get index -1, right, the one in the front if it's equal to 0, and then continue. So if we go through both and then there's no continue, that means the cell can be, so res plus plus, right? This cannot be monitored. And at the end I will return res. Alright, so let's just run through this real quick and see if it works. Alright, this one looks good. Let's see, it's 2257. Put guards and walls positions in rows and columns, sort them, and then check each cell and binary search to find. Oh, I can sort the list. Oh well, it's fine. To find whether a cell has an adjacent guards on the row or on the column. Something like that, right? So OMN definitely, and we'll have to say log MN, because basically it's log M plus log N, so I do think that's that. Okay, now let's take a look. Run it again. Shouldn't have changed anything. Alright, let's see if it passed or there is some error that we need to fix. Well, no error to fix, so that was good. One shot, terrible runtime, which means I need to read through, but you know what? Don't want to do it today. Yeah, but basically was not in a very good mood today because of the injury. You know, you got hurt. You should not be hurt. Should not be hurt. Alright, I'll just keep it there. We're building up this long list. Alright, anyway, that will be it for today. I'll see you guys tomorrow. Adios.